This is video tutorial 8, and in this tutorial we're going to take a look at task groups and how we can use them on the flow diagram to model offshore operations. The starting point for this analysis is the file produced during tutorial 5 where we looked at vessel properties, and so far we haven't edited this file. See, we have 3 tasks in the file: mobilize import, which is fully suspendable; work offshore, which is suspendable if the vessel holds station; and the fully suspendable demobilize import task. We can see that the work offshore task has a duration of 2 days at the given metocean limits. This is quite a long task, and one that we can probably model in a little bit more detail by splitting it out into smaller tasks rather than one large task of quite a lengthy duration. By modelling it as discrete tasks, smaller discrete tasks, we can better analyse the analysis. So let's just start the process of adding 3 new tasks. We'll fade through that quickly. So we now have phase 1, 2 and 3 of work offshore. The duration of these tasks totals the 24 hours that we had previously, and we can see that the metocean limits change as these tasks progress. Each one is a different piece of work. These are all not suspendable tasks. The issue that we now have is that the work can suspend in between these tasks and can fully suspend. The vessel can return home from site to port, and this isn't actually what we had in our initial case. In our initial case we required at least 2 days of the vessel holding station at site, and the work couldn't suspend in between. Now work can suspend in between, and this isn't really what we want. We can get around this problem by adding a task group to the flow diagram. We can do that here by clicking on the Add New Task Group icon, and if we just position that under phase 1 and drag it out past phase 2 and 3, that puts these tasks into this group. We can give this group a name to help us identify it. And we can set various parameters on the group, metocean limits and such, like vessels and locations, and we can use these for inheritance. Just note briefly that the vessel has been removed from the tasks upon adding that group. So we'll assign the construction vessel and the offshore location to the group. We can also set some repeats. We can set some operating metocean limits if we want to. We're not going to use these here. And we can also set the suspendability of the group, and we have the same options available to us as in the tasks. In this case we're going to set this group to be suspendable if the vessel holds station. And we can see now that the vessel we applied to the group has been applied to the tasks, and we can also see it there summarised on the group card. And what we now have is a setup where each task is not suspendable, and the connections between the tasks, so the connection between phase 1 and phase 2 and the connection between phase 2 and phase 3, must conform to the if holding station suspendability of the group. So the vessel can't leave site for port or for any other location during the analysis of the entire group. If weather forces the vessel to depart the site and breaches the requirements of the group suspendability, a later weather window is sought to do this work in, and the entire group is delayed until each task conforms to its specification and each group to its. We can see here that the vessels on the task are forced to inherit from the group because the group is not fully suspendable, and that the location is also forced. If the group is fully suspendable, we can set these on a case-by-case basis. We can also see that the metocean limits have inherited from the group, and this is not what we want, so we'll just turn these off. And we'll repeat this process on our other tasks in the group, so just flicking off the inheritance of the metocean limits so that each task takes its own limits rather than those specified on the group. The nice thing about being able to inherit is that we can quickly and easily set up changes to large numbers of tasks by placing them in a group. For example, we could place a fully suspendable group around all of the tasks and groups in our analysis. We could set a vessel on this task and force all remaining groups and tasks to inherit from this top level one. And then if we wanted to change the vessel in our analysis, if we were, say, optioneering vessels, we just have to change it on the main top level group, and it propagates down across all the cards. We've now got ourselves set up with something which mimics the initial setup but with additional detail. So let's give this a run. We'll provide a description. IHS will be fine. And we'll click Run Analysis. A Mermaid will now go and work through all the years of MetOcean data, looking to satisfy the constraints placed on both the tasks and the groups, as we discussed. That's the analysis finished. So we can now move to our Analyze tab and load up the results source, as we always do. And we see the usual summary. Now we can have a look at the summary table and dig into our data a little bit. So that's the end of the tutorial on groups and their use in flow diagrams. And during this tutorial we've seen two key concepts which are quite important for modelling offshore operations in Mermaid. The concept of group suspendability, whereby we force vessels to remain on location or allow them to leave in between tasks within a group, and also the concept of inheritance, which allows us to quickly and easily set up multiple tasks and groups with shared properties and shared parameters. As a final point, we should note that some logic is applied by Mermaid to the suspendability of tasks and groups contained within other groups, and it limits the options in the drop-down menu when selecting suspendability to ensure that a task or group is constrained at least as strictly as the item which contains it, meaning that we can't, for example, put a fully suspendable task in a not suspendable group. That's the logical thing to try and do. If the group's not allowed to suspend, then the task can't suspend either.